thank you for all being here on the last session of a very busy conference. I'm excited that I'm not speaking to an empty room. So my name is Kevin Hannon. I'm a senior software engineer at Red Hat. And
hello, I'm Marcin, tech lead at Google.
So can I get a show of hands? Who here knows what a working group is in Kubernetes? Okay, so I'll explain it. So as we all know, Kubernetes has these things called special interest groups. These are essentially the people that own a lot of the code in Kubernetes. What's important for batch is like SIG node, SIG apps, SIG autoscaling, and SIG scheduling. And generally, it's kind of difficult to get features into Kubernetes because sometimes these groups are a little bit siloed. The idea of a working group is to try to say, hey, we have a major pain point in Kubernetes. And back in, I think it was 2022, the working group batch was created to kind of address the problem that running batch workloads in Kubernetes is way too hard. So generally, there was a large amount of people having their own APIs for running batch jobs. Honestly, it was pretty chaotic. And there was kind of this, we saw this need to improve the batch API ecosystem around Kubernetes. And try to make like a single API workload for actually running batch jobs. Marcin will talk about Kueue in the second half of this talk. But for the rest of this talk, I want to talk about what we're doing to make the job API useful for folks that want to run batch workloads. And so if you want to get one takeaway from this talk, if you're interested in this, please join the batch Slack channel. That's where most of our discussion happens in real time. Follow the SIG projects like Kueue, and I'll talk about JobSet. And this is and you can join the mailing list too. There will be some discussion on there. And we also have bi-weekly meetings. We have a once a month meeting that's friendly for Europeans, and once a month meeting that's friendly for our Asian coworkers and West Coast folks. And all this is on the QR code, has some information about how to join these meetings and everything. So hope to see one of you there. So without further ado, what I wanted to talk about was the Job API. So who here has actually used the Job API? All right, a few. So generally, at a high level, it looks very similar to like a deployment. We have a pod, and we have this thing called parallelisms is a number of replicas. And so this is kind of how many pods are replicated. And then we have a thing called back-off limit. I'll talk a lot about that in this talk, so I want to highlight that. This is just this idea of how many retries a pod has before you declare the job as failed. And so the next step, what we saw, one of the major problems we saw in this space was that most folks that are running jobs, they want communication between their pods. And they also want a stable name for their pod rank. So if you're running like an MPI like job, you might have like a rank 0 pod and your rank 1 and 2. You want to make sure you can communicate to your rank 0. And this is kind of this idea of an index job. You can have this feature by a completion mode called an index, and then if you couple that with a headless service, you're actually able to get all your pods to communicate to one another. It's kind of an implementation detail, but it's actually, if you want to build like a workload that requires communication between your pods, it's necessary to create this. It's necessary to create the headless service in conjunction with an index job. So one of my favorite features I've found in the Kubernetes community is this one called pod failure policy. It seems so simple, yet it really showed a lot of problems in the ecosystem. I was not the author of this one, but it was fun to follow this one over the years and all the discussions that were made, even around stuff like, hey, my pod failed due to this exit code, and trying to standardize on some exit codes was kind of a fun little thing. But generally, the idea is we have this pod failure policy stanza and YAML, and we say, hey, what do I want to do if I get a certain exit code of a container, and I want to go ahead and fail the job? This matters a lot for, if you're running a GPU workload and you have some kind of segmentation fault, you don't want to keep retrying. I've seen, some people are paranoid, so they'll set their retry limits to like 1 million just so they can get their jobs to keep running. And so we find that we want to make sure to kick those jobs off if they're failing for an application failure. So that's like on the left-hand side, that's this idea of using pod failure policy for exit codes. An area that was really interesting was seeing how can you do the counterpoint where how can I not decrement the retry count if I have an infrastructure thing like my workload was preempted, I shouldn't be penalized, and I should not say my job failed. That was my stupid cloud vendor preempted me, so why should I be penalized for that? Well, that's kind of one other use case we have for the pod failure policy. And like when stuff is preempted or other things, you would have a special condition called disruption target that you could use to not fail your jobs. We have the author I see is here that actually created this feature, pod success policy. But this is kind of the counterpoint of when a pod of a certain index succeeds, I want to mark my job as successful. This highlights a few of the features that this working group has sponsored over the last like 2 or 3 years. Most of these are available in most Kubernetes clusters anywhere now. My first KEP was actually the pod replacement policy in Kubernetes, which this was this idea of making sure that when a terminating pod, like sometimes you would see a pod go terminating, then the job controller would create a replacement, and this would cause some problems with PyTorch frameworks because they would require the same, you would have like duplicate ranks and things go haywire. So that's that one. By far the most interesting thing in this space is seeing how many people are starting to actually become more aware of what the Kubernetes community is doing. I have a couple issues where people are saying, oh, hey, this thing that the batch working group people are doing is pretty cool. I would like to build this integration. Why don't I go ahead and do that? Like, if you're not familiar, Airflow, workflow engine, it was really high it would run it would run pods on Kubernetes, and there was a request a few years ago to actually have a Kubernetes job as a first-class support. And we've kind of been seeing that over the last year. More and more frameworks are starting to use the Job API because it's more useful, so that's great. The last area that's kind of an interesting one is seeing the Kubeflow community. Like when they're one of the first people for running a lot of distributed ML workloads, and they run into a lot of problems where their users want the Job API support, but it was actually really difficult to support this with Kubeflow because they had pod and services. And I'll talk a little bit about what the approach they have done, but these are other features that they have requested from the Kubeflow community, and yeah. So the last area for a workload that we know was not well served by the Job API was this concept of a distributed job. So this is idea of I have multiple templates. So I might have like, with popular now is Ray for serving or for training. You might have like your Ray pod is a different template from your parent Ray pod is a different template from your worker pods, and you kind of want failure policies to be smarter to say, like, if my leader fails, my entire job needs to go down, but if my workers succeed, I can kill the leader and I can mark my job as success. And startup policy was a big one. Like if you're running like an MPI job, you might want the MPI launcher to run first and set up all the stuff it needs, and all your workers are able to communicate to the leader or the launcher or whatever. And we want to make sure they start in order. And we also want that implementation detail of like the headless service and everything to be there so that our pods can all communicate. So that's the motivation between the project called JobSet. The idea is, surprise, surprise, it solves all the use cases we mentioned about a distributed job. But the idea is we kind of wanted all these feature requests in JobSet and allow building, make sure all these things are set in stone so we can all kind of build off of this. So our first use case was saying, can we represent a PyTorch job pretty simply? And this is a pretty simple example, but it actually works. And if you try to do this with a job API, if you don't have the headless service, it actually won't work because you can't communicate with your pod. So that's like the first step with the job set we wanted to try was just, can we run a simple PyTorch job? The next one is this idea of success policy. So can I say, if all my workers are, if my workers finish, I want to mark my job set as complete. I don't really care what the leader does. The leader is only there to coordinate work, and then I don't really need him to finish. And so this kind of, it's one of the main use cases for like worker and leaders. Startup policy was a feature where we wanted to make sure that like the driver would actually start first. And if you're not familiar in Kubernetes, we have this concept of readiness probes. So our basis for this is saying a pod is considered ready if it passes the readiness probes. So the idea is, and a lot of projects will set these. And so once these things are passed, your pod is ready to, can be considered active or ready actually. And then after that stage, it goes on to the workers and starts those so that if your driver had to be set up and running, that's why it's there. Now, one of the things that's been interesting to see with JobSet is I view the Kubernetes SIG projects as dog fooding for users because we want to make sure the APIs we build are useful. And JobSet, one of our main goals, was really to use concepts like the pod failure policy of a job and how does that work if you have a higher level controller and how do you react to that. And so the idea, this is a relatively new feature, but for the failure policy, it was this idea of saying if my leader fails, I want to fail a job set. If it fails due to a pod failure policy, I want to go ahead and either fail it or restart based off of the rules you set in stone. An area that I think has been super exciting to see, and there was a talk, I think it was yesterday, talking about the next rendition of the training operator in Kubeflow. And if you see in the top little icon there, JobSet is playing a crucial component in the next version of the Kubeflow training operator because they want all the functionality that the Job API has provided over the years, and they want to kind of build off of that and start really thinking more about how to improve the machine learning lifecycle rather than having to figure out all the Kubernetes stuff. And without that, I like the co-speaker.
Okay. Hello, everyone. Let's get to Kueue. You might have seen the keynote, so you may already have a little bit of introduction into what Kueue is about. But let me start with why we started this project in the first place. So users in Kubernetes run into a number of problems. For example, which of the 100 training jobs or data processing pipelines should be running at the given time on limited resources? Kubernetes doesn't handle this well. How to ensure that all parts of a job will quickly schedule before actually starting the process. How to allow users to use as many spot instances as possible, but limit their on-demand capacity. How to do all above without replacing lots of stuff in the Kubernetes. How to set up a resource quota so that they can be fairly distributed among the teams that are using them or not using them. And in the end, how to schedule workload based on their networking needs. So Kueue is a kind of batch scheduling and admission system that decides which of the jobs run at the given moment and on which of machines. It provides advanced resource controls like hardware-specific quota. So with Kueue, you can specify the quota for a particular type of machines. For example, set separate quota for the newest and greatest GPUs and separate quotas for less fancy CPUs and GPUs. There is a concept of quota sharing and borrowing so that you can set a quota for a team or multiple teams, and if one of the team is not using them, then others may borrow it. We provide different policies for preemptions and quota reclamations. In case of borrowed quota, we have job level priorities, and Kueue doesn't replace any of the Kubernetes component. Kueue tries to meet users where they are. It provides integration with Kubernetes Job. with all of the Kubeflow portfolio, with RayJob, with JobSet, with standalone pods, with pods that are grouped via annotation, with deployment, stateful set, and very, very soon with leader worker set. Okay. Someone is calling you. Please take it. Okay, so Kueue has been around for quite a while. It's relatively new, but also relatively mature project. We have a number of users that are using it, and those users are requesting more and more features. One of the very important features for our user was to be able to take advantage of networking structure. So many of ML workloads require quite a lot of communication. So pods are talking to each other. And the further the pods are, the more problems come with the communication. The latency is bigger, the bandwidth is smaller, and because of that, the computation may take longer. GPUs are super expensive these days. And the sooner the computation completes, the cheaper the computation is. Okay, so what does the topology of the network look like? So probably you have been running a couple of workloads in the cloud already. So the first thing of the topology is the zone. So most of the clouds have a concept of zone. Zone, basically, you can think about it as a building in the data center. So they have a data center, I don't know, somewhere in Oregon, and they have 3 buildings. Each building is a separate zone. Inside of these buildings, they have rooms. These rooms may be called differently from cloud provider to cloud provider, but let's use a name like block for them. Inside of these rooms, they have big racks where they put their servers. Their servers, well, are in the rack, and there are physical machines. Each of the physical machine run 1 or more VMs. Obviously, the most bandwidth and the lowest latency is at the VM and physical layer. Then the next thing is the rack. In rack, each rack usually has its individual switch and a lot of throughput and very, very, very small latency. Latency is bigger when communication goes from one room to another room, and even bigger if it needs to go from one building to another. So workloads would like to take advantage for it. For example, a very talkative workload may say, hey, I require to run on a rack. If you don't have a rack available for me, and I have 20 pods to run, please keep me on hold, because running this computation in a scattered way doesn't make sense at all. Okay? This is one sort of workloads. Other workloads may be a little bit less talkative and say, hey, I would prefer to be on rack, but if you could put me on a block or in this room in the data center, that would be good enough. So to allow that, we introduce 2 annotations that you can put on your workloads. You can put either I require topology or I prefer topology. And in the value of this annotation, you will need to specify one of these layers that are here. These layers are obviously specific to cloud providers or to your on-prem environment. They may look differently on cloud providers. They may have different values. However, Kueue tries to understand all of them and build a tree-like structure out of them. OK, how does it look like? So the workload puts the annotation. It goes to Kueue. Kueue checks what is available in the cluster and decides whether the workload can be admitted or not. If the workload can be admitted, it is admitted, the pods are being created, and while the pods are being created, we catch each of them and assign them the right topology via a node selector. Okay, next big thing is in Kueue is pair sharing. So as I said, you can specify a quota in Kueue. You can specify this quota for different quota for different teams. You can put teams in a cohort so that one team can borrow unused capacity from the other. But there is a problem what to do if suddenly there is a lot of unused capacity. What to do is how to split it. If we split it in a first come, first serve manner, then the teams that are more east, like on the East Coast, would be unfairly advantaged because they are coming to work earlier and they can grab unused resources. That's not fair, and the team on the West Coast would complain. So to fight with that, we are introducing fair sharing in Kueue so that the unused capacity can be distributed across the team based on their needs. If only one team needs extra capacity, then this team gets it. If suddenly some other team starts to need it, then the team that got too much capacity gets a couple of preemption, and the team that just show up with more needs will get the extra capacity. Okay, so how do you enable fair sharing? You need to slightly modify Kueue config. Each cluster queue in cohort can specify some weights that can influence fair sharing. For example, one team can, or one cluster queue can be 3 or 4 times more important than the others, and in case of fair sharing, they should get more resources than the others. Fair sharing is done within the cohort, so if you have separate cohorts, then separate cohorts don't share, and there is no fair sharing between them. And the new feature that is not yet completed, but is coming to Kueue very, very shortly, is hierarchical cohorts. So a couple of our customers want to put their entire organization inside of Kueue. Entire organizations have complex needs. They have company politics, and usually they have 3 structures. Right now, Kueue offers you a flat structure. So you can have cluster queues or teams, whatever you call them, and you can put them in a single group. But that doesn't match well with complex organizations. So with the next release of Kueue, we'll introduce hierarchical fair sharing so that you can build a hierarchy of your organization and then ensure that this fair sharing happens at the appropriate level of the organization, so that the teams first try to consume and distribute free resources within their all small cohorts. So for example, one manager wants to distribute first their unused resources to his team. Then maybe borrow it to the neighboring manager under the same director. Then this goes upper. One director would like to fulfill the needs of his organization before starting borrowing to some others, and so on, up to the very top of the organization. And this thing is coming in the next release of Kueue. Okay, what else do we have in Kueue? Kueue is run by Kubernetes objects. All Kubernetes objects sits in YAML. Kubernetes administrators need to play with YAMLs, and some of them don't really like playing with YAMLs too much. And many things cannot be easily done with YAMLs, and putting some extra automation for common tasks in YAMLs can be a little bit cumbersome. So to fight with that, we introduced actually half a year ago something that we called kubectl. kubectl is a kubectl plugin managed by Kueue and provides you with quite nice functionality to manage your Kueue environment easier. So you can create Kueue with resource flavors, you can list them, you can delete them, you can list workloads and see where they are in the Kueue. You can pause some admission for workloads, you can stop queues, you can drain them, you can do all of the nice things that otherwise you would have hard time doing with regular kubectl. Okay, so we have foundation layer covered, we have admins covered, but we have researchers that also are not particularly happy with YAMLs. And they have problems. They want to start lots of one-off jobs with complex volume and storage configuration, and with very, very little differences between each of the runs, but still with differences. They would like to use command line as much as possible because they spent like 20 years running Slurm scripts in academia. And they also would like to share their configuration with teammates. So To make their life easier, we are introducing Kueue. Kueue is a tool that provides reusable templates stored on the API server side with a CLI that transforms them into YAMLs and sends the API server for execution. That may sound quite complex, but the bottom line is that we want to create a template, put it in the server, and have it created by the system administrator who knows how to set up the volumes, how to set up the entire Kubernetes environment. We want to give this template to researchers whose only task would be to provide a couple of missing elements in this template, like the command that they want to run, maybe the number of pods they run to execute their job on, or maybe some different requests for the pods, and very, very tiny amount of things that wouldn't require that person to understand all of the nasty details of running bad jobs on Kubernetes. Okay, so the flow is very simple. Admin sets up the template, researcher picks up the template, provides some extra details via command line tool, the job is submitted, and all people are happy. System administrator because he is not bugged by researchers because they have very, very similar environment that they used to have for the past 20 years, and cloud providers are happy because lots of computations happens there. Okay, one more thing here about Kueue, what is supported. So we support Job, JobSet. We are planning to cover all of the things that are covered by Kueue, so all of the APIs there. And one thing that is not mentioned here, I forgot to put this slide somehow, is that we are trying to mimic Slurm environment using this thing. So we want to provide users with command line tooling, command line flags, command line arguments, and configuration that tries to reflect Slurm environment as much as possible. Kueue currently lives in Kueue repository, but hopefully soon we'll get an independent repository and much more spotlight. So a little bit information on how we view this entire ecosystem. So on the bottom, we've got Kubernetes. Okay, so that's given. On top of it, we put an extra scheduling layer that fills the gaps that are in Kubernetes. On the top of it, there is a QCTL tool for administrator and set of APIs for researchers to run their job. And to make their life easier, to allow them to play with command line tools instead of YAML files, we introduce Kueue that encompasses all of the user researcher experience. Okay, that's all what we have prepared for this session. Now there is a time for questions.
It was an excellent presentation. Thank you. The job set is very exciting. My company, we've had a pretty hacked up setup for the past like 5-6 years, where we use a bunch of cron jobs that kind of do sort of like job set. There's one feature that seems like it would be obvious to add, which is not only do you run, say, a set of jobs, but the success policy would have like a finalizer job. That's something we do a lot. We have ML jobs that all run on different data sets and a finalizer that sits there in an init container pending for like days, waiting for all those to complete, watching for their logs, and then kicking off something to upload data or whatever. Just seems like it would be now that might overlap with some other projects, I guess. Like Kubeflow might be, I've never actually used Kubeflow, but I'm assuming that's something where you would do that if this, then that sort of jobs, but I don't know, it's just a thought.
Yeah, in Kubeflow, we are discussing this idea of expanding the sequential execution model because in Kubeflow v2, they're talking about having like a model initialization step where they kind of pull down the images for the first step. I don't know if we've talked much about a finalizer job, but the idea is that we would kind of have a bit more functionality than the startup policy, because for V2, Kubeflow, like they do kind of want the initializer to pull, and then if you have like an MPI job, you might have the launcher be ready in there. I don't know if that doesn't fit. I suggest you could open up an issue on JobSet and we can discuss there.
I was wondering if you had any thoughts towards doing sort of a larger scale aspect of the job flows with something like workflows. So like be able to specify a directed acyclic graph of jobs.
Yeah, so.
Because for our use, we don't do ML, so Kubeflow doesn't really fit as well.
Yeah, so I actually found out at this conference I found it out a few weeks ago, but I got confirmation from a company called Outer Bounds who uses Metaflow, where they were actually using Argo workflows with JobSet. And they actually had, like, we did implement a feature for them to kind of, like, you can always use something like Argo workflows with arbitrary like resources, so a JobSet is possible there to kind of build the pipelines. We've kind of, we've had
to implement our own. But I was wondering if they thought about moving that into batch, because it strikes me as a relatively common, like, for his questions of he wants job A, then job B.
Yeah, I mean, we've always discussed it. I think the challenge is there's a lot of workflow engines, and we don't really, like, Argo is a great tool, a great project, and like we don't really want to take on the burden of trying to create the best workflow engine in the world because everyone else seems to have tried that already. So like we were kind of being a little selective on what we're trying to bring into the project. Thank you.
Thank you.
So the KJob CLI seems like super useful and could be really useful, not just for like one-shot jobs. Like there's plenty of users who would love to just have a CLI to like create a deployment and a service. But like that starts to look a little bit more like a Helm registry with like a slightly nicer CLI on top. How do you kind of see where that line is?
I don't know, to be honest, where this line is. So we wanted to solve the primary problem, which was researchers loving Slurm, but being forced to run on Kubernetes against their will. Okay, so we wanted to create some environment that would gradually transfer them from running things on Slurm with command line tool into embracing YAMLs and loving Kubernetes. Okay, and of course we cannot do it in one hop. We created this multi-hop experience for them. That was the primary goal. Can it be generalized further into deployments, whatever? Yes, it could be, but I'm not sure if it's the right path. So use cases like I want to create 20 different deployments every other day are not that common as I want to create 20 jobs. So probably if we try to generalize it, we wouldn't hit this very small target group. If you belong to this target group and you see the value in expanding KJob in that direction, please reach out to us and we will be very happy to discuss options. Right now, we are trying to complete this experience for batch ML training and HPC type of workloads.
Makes sense.
Okay, anyone? Going once, going twice. Okay, folks, thank you for joining us that late. Have a very, very safe trip back home and see you soon, hopefully in London or next year in the US. Take care, bye-bye.
Thank you, everyone.